In this video, we're going to revise Pythagoras' theorem. Let's have a look at question 1. Select the surds from this list. So a surd is basically a number that involves a square root, but it's also one that involves a number that when you enter it in on the calculator, you're going to get a horrible looking decimal. Let's try the first one. Okay, square root of 25. Okay, it might look like a surd because it involves a square root symbol, but when you press equals on the calculator, you get a nice round number, you get a nice integer there. So that's equal to 5. Okay, this is not a surd. What about square root of 11? Okay, let's try that one and see what we get. Let's see if we get a nice number or we get a horrible looking decimal that goes on forever and ever. We seem to get a decimal here that it seems to go on, and there's no pattern to it. So it's not a well-behaved decimal, this one. So this one is a surd. What about square root of 0.01? Now that might appear to be a surd because it's got a decimal in it. But let's see what happens when we type it in. So square root of 0.01, we get 1 on 10. Or 0.1. This is a decimal that doesn't go on and on forever. This is a terminating decimal, and it looks like a very well-behaved one. So just sort of 0.1, it doesn't have a whole lot of non-repeating digits in it. So that's equal to just 0.1, and this one is not a surd. What about question 2? It says find the value of the hypotenuse in the following right-angled triangle. So this is where we use Pythagoras' theorem, and Pythagoras' theorem goes something like this. C squared, which is the hypotenuse. So the hypotenuse is the side that's the longest, and it's also the one that's sort of furthest away from the right angle there. Okay, C squared is equal to A squared plus B squared. A squared and B squared, well, the A and the B are the two shorter sides. Okay, so C squared is equal to, now you could make either one of these A or B, it doesn't really matter because they're the short sides. We could make that A and we could make that B if we like. Doesn't really matter, okay, since we're adding them together. So 12 squared plus 9 squared. Now, before I guess press equals on the calculator, actually let's do this. Let's just go one step further. 12 squared plus 9 squared. 12 squared plus 9 squared is 225. I just want you to think about something here. Does that make sense to have a side that's 225? It's huge. But the two shorter sides, one's 9 and the other one's 12. They look tiny compared to 225. So there's one more step we need to do. C is in fact equal to the square root of 225. So you have to take the square root to get rid of this squared business there. Okay, and square root of 225 is equal to 15. That makes a bit more sense. Okay, so C is in fact equal to 15 units. Now we can skip that step, in fact, and do that sort of all in one rather than doing the square root as a separate step. So we can do that sort of all in one. Let's have a look at question 3. Find the value of the pronumeral. Now there's the pronumeral there. Notice this time that we have the length of the hypotenuse. Okay, just remember the hypotenuse is the longest side of the triangle. It's the one that's opposite, or furthest away from the right angle. So sort of look where the right angle is. Hypotenuse, longest side. All right? Hypotenuse sounds like hippopotamus, or a big animal, right? So it's the longest side. Now, we're going to use a slight variation to the Pythagoras theorem formula. And this time around, instead of using the plus formula, we're going to use the minus formula. We're going to subtract two sides. So we're going to start off with the largest side there. So A squared is equal to 17 squared minus 15 squared. Okay. Now we know that we're going to have to take the square root of the final answer. So we could in fact do that all in one step, and it saves a bit of time, and you're still showing all you're working out, but you're making sure that you take the square root of the answer because it doesn't make sense otherwise. We can type that as is in the calculator. So square root of 17 squared minus 15 squared. We may get a nice answer there, and we get 8. That's a very well behaved answer. It's not a surd, is it? Okay, it's a nice whole number. Okay, so that's equal to 8 there. Let's have a look at question 4. Find the value of the pronumeral, leaving your answer in surd form. Okay, so surd form means that our answer is going to have that square root symbol, doesn't it? So just keep that one in mind. Now, do we need to find the hypotenuse or one of the shorter sides? Well, let's look at where the hypotenuse is. It's opposite the right angle there. We need to find the hypotenuse, so which means we need to add the square of the two shorter sides. So x squared is equal to, we're going to use the plus formula. So that's going to be 7 squared plus 5 squared. Okay, get rid of that. Now we know that we need to take the square root in the end, so we can take the square root of 7 squared plus 5 squared and kind of sort of do it all in one, right? And we can do that. I think that's easy enough. So square root of 7 squared plus 5 squared. And so we get 8.6. We're not going to write this answer here. That's very important. So we're going to leave it in surd form. Surd form means that we're not going to write the decimal. How we're going to do this is we just type in 7 squared plus 5 squared. We work out what's under the surd first. We get 74. So we're just going to write it as the square root of 74, not that decimal answer that had 8.6 in it. Okay, that is surd form. Okay, let's have a look at another example. Question 5. Find the value of the pronumeral correct to 2 decimal places. So not surd form this time. This time around, we are going to have to write the decimal. So let's see how this is going to work. First of all, do we need to find the hypotenuse or one of the short sides? Let's have a look. Hypotenuse is away from the right angle. We have the hypotenuse, it's 10. So we need to find one of the short sides. So let's write it. B squared is equal to, we'll always start off with the largest number, hypotenuse, 10 squared minus 7 squared. Now we know we need to take the square root, obviously, to get the answer in the end, and we're going to have to round it to 2 decimal places. So B is equal to, we're just going to take the square root of 10 squared minus 7 squared. And I can sense here that we're probably not going to get a very nice answer. We'll get an answer, but not a well-behaved one. Okay, this is another example of a surd, isn't it? Okay, now we get this. All right, no pattern to it again. All right, so that's obviously a surd, but we're going to write it in decimal form because it says so. So that's going to be 7.14, okay, and the number next to the 4 is a 1, which means that 7.14 can stay as is. We don't have to round the 4 up, so that is correct to 2 decimal places. Okay, so 7.14 units. Now let's have a look at question 6. Test if the following triangles are right angled. And this is where we can use Pythagoras theorem again. We can look at the 2 short sides, add them together, take the square root, and it should equal the hypotenuse. So let's try that. So if we try 1 squared plus 2 squared, okay, let's see what we get there. Okay, so 1 squared, which is a nice number, which is just the number 1, plus 2 squared, we get 5, and we need to take the square root of that. Okay, and all right, if we take the square root of 5, okay, does it equal to 3? Let's try. Okay, square root of 5, you get 2.236. Okay, 2.236, which does not equal 3. So this one is clearly not right angled. Okay, so we can't actually show. Okay, we can't actually show this symbol here. All right. So that was wrong to even put it there in the first place. So this is not right angled. What about this triangle here? Let's see what happens. Okay, and what we could do is we could do this a little bit quicker than the last example, and we could write it like this. Okay, square root of. Now let's see if we can get 39 by adding the square of 36 and 15. Take the square root, and we should get 39 as an answer. Let's try that and see. 36 squared, so that's one of the short sides, plus 15 squared. And let's see what we get there. Hopefully we get 39. I've got a feeling we might. Let's see. Would be wrong. Ooh, we get 39. And that happens to equal our hypotenuse. So this one is right angled. Okay, so that's correct to have that symbol there, the right angle symbol there, that box there. All right. Let's have a look at question 7. Okay. And question 7, I'll just fix that. Test whether each triad is a Pythagorean triad. So it's a bit like the last question. It's a bit like question 6, just without the triangle. So if you want, you can even imagine a triangle. Okay. Imagine this is a triangle that has a short side of 15, another short side of 20, and a hypotenuse of 25. And you want to test whether this triangle is in fact right angled. That's what a Pythagorean triad is. It's just the 3 sides of a triangle without showing the actual triangle. So what we're going to do is we're going to use a little bit of a shortcut here, which makes it a lot easier. We're going to take the 2 short sides, take the square root, and then see if we get 25. So square root of 15 squared plus 20 squared. And let's see what we get. And if we get 25, then it is a Pythagorean triad. Okay, so square root of 15 squared plus 20 squared. So it's like we're trying to do Pythagoras theorem here. And guess what? We get 25. So it certainly does work. So that does equal 25. So this is a Pythagorean, therefore this is a Pythagorean triad. All right, what about this one? 20, 21, and 29. This one could also be a Pythagorean triad. We might be lucky in 2 occasions. Let's try that again. And I might actually throw in one last example after this one, and I'll just add an extra one here. So 20 squared plus 21 squared. If we do that, do we get 29? Drum roll. Do we get 29? We do. Right, so this one also is a Pythagorean triad. So therefore, Pythagorean. Okay, hopefully you can read that. Now, I'm going to give you maybe just one more to try. What about this one? Okay, so I'm just going to write it up here. What about this one? 1, 2, and 3. Is this one a Pythagorean triad? In other words, could these be the 3 sides of a right angled triangle? Maybe, maybe not. Let's see. If we do the square root, and we'll do what we did with the other examples, 1 squared, right, plus 2 squared, do we get 3? And we don't. And that's like the previous example, wasn't it? So we did an example where these were the 3 sides of a triangle. We thought it was a right angled triangle, and it turns out that it wasn't. And you can see here that we should have gotten 3 as an answer, but we didn't. So this one is not a Pythagorean triad. Okay, I can't fit it there, but this is not one of those. Let's have a look at the last one. Okay, you've done well. If I've held your attention so far, I've done well to have held your attention. Last one, question 8. A ship sailed 25 kilometers west and then 40 kilometers north. How far is the ship from its starting point, correct, to the nearest kilometer? Okay, so first of all, why don't we draw a diagram to see what's going on here? All right, so a ship sailed 25 kilometers to the west. So we're doing this, aren't we? So the ship's doing this way, right? So remember, okay, I might actually draw a compass rose first, so just so you can see what's going on here. There's north, okay, east, south, and west. So the ship, okay, is sailing to the west first, so 25 kilometers. So I might just draw that there. Yep. So there's 25 kilometers to the west, okay, that way, and then it sails 40 kilometers to the north, okay, in a northerly direction. So there's 40. And what we want is we want the distance the ship is, so there's the ship right there, from its starting point there. Okay, so what we want there is that dotted line. Now, the line, the north-south line and the east-west line, okay, they're going to form a 90-degree angle. So now we've formed a right-angled triangle. Okay, so let's call that C for our hypotenuse. Okay, we don't always have to use the letter C. So C squared is equal to, because we're trying to find the hypotenuse, we're going to add the square of these 2 numbers. So that's going to be 40 squared plus 25 squared. And might as well just take the square root all at once. So that's going to be 40 squared plus 25 squared. And let's just enter that in our calculator. Square root of 40 squared plus 25 squared. And we get 47.1699. Okay. But the question says correct to the nearest kilometre. So that's going to be 47 kilometres to the nearest kilometre. So that's how far the ship is after sailing to the west and then north.